How invisible bonds control everything you touch. You never see them. You never feel them directly. Yet every solid surface, every liquid drop, and every breath you take depends on invisible bonds holding matter together. Most people think the physical world is defined by shape and weight, but chemistry tells a different story. Reality is governed by connections at a scale too small to notice. Bonds between atoms decide whether something is hard or soft, fragile or flexible, alive or inert. And today, those bonds shape technology, health, and the limits of modern life. To understand why this matters now, we need to strip the world down to its fundamentals. Everything you touch is a temporary agreement between atoms. Electrons shared, charges balanced, forces pulling and pushing in constant negotiation. When those bonds change, properties change instantly. At first, scientists believed bonds were simple links, fixed, predictable. But deeper study revealed nuance. Some bonds stretch, some snap under pressure, others rearrange without breaking at all. These behaviors explain why materials fail, why drugs work, and why systems age. One subtle shift in bonding can transform behavior completely. A flexible material becomes brittle. A harmless substance turns reactive. A stable structure collapses without warning. The world does not change gradually at the molecular level. It switches states. This is where the story begins, with invisible bonds quietly deciding how long things last, how they interact, and how easily they can be changed. Bonds so small they escape attention, yet powerful enough to control everything you touch. Once scientists learned to observe invisible bonds, they learned to manipulate them. Heat stretched them, pressure compressed them, electricity rearranged them. Chemistry became the art of guiding these forces without ever seeing them directly. At first, this control unlocked remarkable progress. Stronger materials, lighter structures, medicines designed to bind precisely where needed. Bonds became tools, engineered to perform specific tasks. But bonds do not exist alone. Changing one affects others. Strengthening a connection here can weaken stability elsewhere. Chemistry is a network, not a chain. As manipulation intensified, complexity followed. Materials behaved differently under real-world conditions. Stress accumulated. Fatigue set in. Invisible cracks formed at the molecular level long before physical failure appeared. This is where early tension arises. The same bonds that grant durability also store stress. When pushed repeatedly, they remember, not consciously, but chemically. Repeated strain alters arrangement. Alignment shifts. Weak points emerge. These changes are difficult to detect until it's too late. By the time a structure fails, the chemistry has already decided the outcome. The visible break is only the final moment of a long molecular story. Understanding bonds gives power, but it also reveals vulnerability. Control at the smallest scale demands humility at the largest. Invisible bonds do not forgive overconfidence. The conflict deepens when invisible bonds are pushed beyond their natural limits. Modern life demands materials that last longer, perform harder, and adapt faster than ever before. Chemistry responds by stretching bonds closer to failure. At the molecular level, stress does not disappear. It redistributes. Bonds absorb pressure, shift alignment, and weaken incrementally. Each use leaves a trace. Each cycle changes the internal landscape slightly. What looks solid on the outside may already be compromised within. Scientists studying material failure uncovered a troubling pattern. Most breakdowns are not sudden. They are inevitable. Chemistry records every strain event, silently accumulating damage until a threshold is crossed. This buildup carries emotional weight because it mirrors systems beyond materials. Infrastructure, technology, even biological systems fail the same way, not from one dramatic event, but from countless small stresses ignored over time. Attempt to reinforce bonds introduce new trade-offs. Stronger bonds reduce flexibility. Rigid systems resist change, then shatter under unexpected pressure. Chemistry forces a choice between resilience and adaptability. This is an emotional peak. The realization that strength alone is not safety. that invisible bonds can only absorb so much before chemistry demands release. The world around you feels stable because bonds are holding, but chemistry is always counting. And when the balance tips, change happens instantly. The climax comes when we understand that invisible bonds are not permanent guarantees. They are ongoing negotiations. Every material, every structure, every system exists in a state of chemical compromise. Bonds hold until conditions shift. Heat rises, pressure increases, time accumulates. When thresholds are crossed, chemistry responds without warning. This realization reshapes how we think about durability. Longevity is not just strength, but balance. Systems designed with flexibility survive longer than those built for maximum rigidity. Chemistry rewards adaptation. The resolution lies in designing with bonds in mind. Materials that heal themselves. Structures that redistribute stress. Chemistry guided not just by performance, but by longevity and failure modes. Understanding invisible bonds turns fragility into foresight. It allows anticipation instead of surprise. It shifts design from reaction to prevention. Everything you touch is a lesson in chemistry, not static matter, but dynamic relationships. Bonds forming, stretching, and breaking in response to use. When we respect those invisible connections, we build a world that lasts. When we ignore them, chemistry eventually corrects us. Subscribe to join the journey.